So we've introduced this quantity called entropy and seen how we can determine if the entropy change for a reaction is positive or negative. By the way, we need to keep track of what we can and cannot determine from balanced equations. We cannot predict the sign of the enthalpy change from a balanced equation simply by looking at it, but we can often predict the sign of the entropy change. So, given these quantities, how do we tell if a reaction is spontaneous or not? For that, we turn to the second law of thermodynamics. The second law of thermodynamics deals with the entropy of the universe. It states that the entropy change of the universe is positive for any spontaneous process. Measuring the entropy of the universe seems rather daunting, but we can restate this in terms of system quantities. The relationship we use is this: delta G equals delta H minus T delta S. G is called the free energy, so delta G is the free energy change for the system. Delta H and delta S are for the system, not the surroundings or the universe. T is in kelvins, so it is always positive, but as we know, delta H and delta S can be either positive or negative for a given process. Signs are important since it's ultimately the sign of delta G that will dictate spontaneity. Our criterion for a spontaneous process is one in which delta G for the system is negative. If delta G is positive, we would say that the process is non-spontaneous.